Normal distribution question. So J is assumed to be normally distributed with a mean that we don't know and a standard deviation we don't know, but we know that the probability that it's less than 493 is 0.05, and the probability that it's greater than 502 is 0.025. So we can use the inverse normal to change these into z values. Now the first one's fine because inverse normal only works for less than. So we've got an area of 0.05. We don't know the standard deviation, so we're going to go with the normalised version, which is 1 and a mean of 0. And we're going to store that into A. And we know the formula is Z equals x minus mu over sigma. So from this, I know ZA times sigma is 493 minus mu. From the other fact, we can't work with greater than on inverse normal, so we swap it to be less than, and it's 1 minus that value, which is 0.975, and this gives me a different z value of 1.95, which I'm going to store into B. And this gives me that ZB times sigma is 502 minus mu. So to find sigma and mu, I can just use the simultaneous equations function on my calculator. So I've got A sigmas plus 1 mu is 493, or B sigmas plus 1 mu equals 502. Sigma's 2.4966, so 2.50 to 3 sig fig, and mu is 497, which is 497 to 3 sig fig. And these are the values we're then going to use for the rest of the question. So actually we know that the juice is normally distributed with a mean of 497 and a standard deviation of 2.50. They want the probability that it fails to meet, so it means it's not got more than, so it's got less than 492, it's got too little in it. Menu 7, normal CD, so from minus 1000 to 492. Sigma we've said is 2.50, mu is 497. We get a probability of 0.0228 to 3 sig fig. Part C is then going to be a hypothesis test. So this is a normal hypothesis test. So we're comparing the means. And our original assumption is that actually the mean is what we said it was, of 497. And they want to know if it's changed so that it's no longer equal to 497. So our juice itself is normally distributed, which means that the means of the samples of juices will be normally distributed with a mean of 497, but a standard deviation or variance of 2.50 over 20. We need to take account of the size of the sample we're trying. So we want to do two tests because we're not equal to. So is it less than 498.7, the mean, or is the sample mean greater than 498.7? So we're going less than 498.7. The mean isn't 2.5, it's the square root of 2.50 squared over 20. And, yep, so that's 0.9988. Above it, 498.7 up to 1,000 is 0.00117. Now what are we comparing this with? Well, we've got a 1% significance, but it's a two-tailed test, so we're going to compare it to 0.005. This is clearly greater than, but this one in fact is less than, and that's all we need to have sufficient evidence to reject H0. Therefore, the mean volume of juice has changed.